Hello, my name is Benjamin Lee, and I just want to welcome everyone. It is now 1 p.m., so we'll begin our presentation shortly. Today we'll have our presentation on land use and development planning near transmission pipelines. For help during today's webcast, please feel free to type your questions in the chat box found in the webinar toolbar to the right of your screen, or call 1-800-263-6317. For content questions, please feel free to type those in the questions box, and we'll be answering those after the presentation. Here is a list of sponsoring chapters, divisions, and universities. I'd like to thank all of the participating chapters, divisions, and universities for making these webcasts possible. These are the list of upcoming webcasts. To register for these upcoming webcasts, please visit utahap.org webcast. We're now offering distance education webcasts to help you get your ethics or law credits before the end of the year. These webcasts are available to view at utahap.org webcast archive. Follow us on Twitter or like us on Facebook to receive up-to-date information on planning webcast series sponsored by chapters, divisions, and universities. To log your same credits for attending today's webcast, please go to planning.org/cm. At this time, I'd like to introduce our moderator for today. James Davenport has been with the National Association of Counties since 1998, where he serves as a program manager for the County Services and Innovation Department. He provides education and technical assistance on transportation, sustainability, and resilience issues to county government officials and staff. James also conducts extensive outreach for NACO and represents NACO at pertinent national and regional meetings. Before coming to NACO, James was with the Metropolitan Washington Council of Governments from 1991 to 97. He holds a bachelor's degree in economics from Virginia Polytechnic Institute and State University, and a Master of Urban and Regional Planning from Virginia Commonwealth University, and an Adult Education Certificate in Historic Preservation from Goucher College. And our presenter, Julie Halliday, is a Senior Program Manager for the Pipeline and Hazardous Material Safety Administration, located in D.C. She works with pipeline safety stakeholders to promote recommended practices for land use planning and development near transmission pipeline. Julie has many years of experience in the natural gas industry in engineering, operation, and maintenance, and construction. She has Bachelor of Science in Civil Engineering from University of Illinois and an AAS in Information System Technology from Northern Community College. At this time, I'll hand it over to Julie. Hello?
Ben?
Yeah.
Okay, we're going to go ahead and come over to our screen and, whoops, I'm going to turn it over to James here. Are you on mute?
Can everybody hear me?
Yeah, sounds good. Hello?
Yes, can you hear me?
Yes, you're...
Can you hear me now?
Yeah, we can hear you.
Okay. Guess I was on mute. Sorry about that. Again, good afternoon and welcome to the webinar, Land Use and Development Planning Near Energy Transmission Pipelines. My name is James Davenport, and this presentation today is presented to the APA Planning Division and chapter members, on behalf of Ohio State Planning Webcast Series, the APA County Planning Division, the USDOT Pipeline and Hazardous Material Safety Administration, or PHMSA, and the PIPA Communications team. Again, my name is James Davenport. I'm a program manager at the National Association of Counties, and I'll be moderating this webinar today. I'm pleased that you selected this webinar and look forward to the insight and information from our presenters, as well as your comments, questions, and concerns. I hope that you find this webinar a helpful tool in the exchange of information. This webinar is being held as part of the PIPA Communication Team Outreach Program. PIPA, or the Pipelines and Informed Planning Alliance, was a stakeholder initiative led and supported by the USDOT PHMSA. PIPA's goal was to reduce risks and improve the safety of affected communities and transmission pipelines through implementation of recommended practices related to risk-informed land use and development near transmission pipelines. In December of 2010, PIPA released the PIPA report titled Partnering to Further Enhance Pipeline Safety in Communities Through Risk-Informed Land Use Planning. It is a mouthful. Which offers 43 recommended practices for local communities, developers, pipeline operators, and real estate commissions to use to help reduce the safety risks that result from the growth of communities near pipelines. So the purpose of today's webinar is to gain an understanding of pipeline fundamentals, review the types of energy pipelines and the commodities transported through them, discuss the benefits and risks of pipeline hazards, gain an understanding of what role federal, state, and local governments play in pipeline safety, review some of the key recommendations from the PIPA process, and we will cover resources, including federal grants, that are available to your community to support your evaluation and implementation of land use planning tools when development is planned near transmission pipelines. So now, Julie is now the next speaker, so I'll hand it off to you. Thank you.
Thanks, James. What we have here is a map that shows a network of the 175,000 miles of hazardous liquid pipelines in red and a network of the 321,000 some miles of gas transmission pipelines in blue. What you don't see on this map are the more than 2 million natural gas distribution pipelines and the 114 active liquid natural gas plants. In the United States, energy pipelines are extremely important to our social and economic well-being. You might say that they are the arteries that carry the lifeblood of our national economy and security. Every year, more than 66% of our oil, natural gas, and hydrocarbon resources are moved through this vast network of pipelines. Pipelines are the safest practical mode of transporting and distributing this tremendous volume of energy products. However, like any industry that deals with hazardous material, there is always a potential for risk. When pipeline accidents occur, the impact can be devastating. Let's take a look at how pipeline works. Basically, gas transmission and hazardous liquid pipelines work in much the same way. Product is put into the pipeline, pressure is applied by some type of a pump, the product is forced to flow toward an area of lower pressure. The flow is maintained until the product reaches its destination. And along the way, as pressure is lost due to friction and heat, compressors or pumps continually boost that pressure to keep the product flowing. Various system components such as valves, storage tanks, and metering stations are used to direct control and measure product flows. The products are extracted or removed from the pipeline at their destinations. At that point, the products are either stored, transferred to alternative transportation modes, or consumed. Essentially, you can break down pipelines into 3 different types. The first are the gathering pipelines. So if you look along the left side of the schematic, you can see the gathering lines are gathering gas and crude oil from the production wells, and they're transporting the product to the facilities for processing and refinement, or to transmission pipelines. PHMSA regulates only a small portion of these gathering lines, and currently we don't collect data or maps on these unregulated lines. Some states do regulate these lines, but most do not. Typically, they're out in very rural areas. Transmission pipelines, our second category, move the gas and hazardous liquid long distances across the country, often at very high pressure. And when you see the maps that we have later from the National Pipeline Mapping System, these are the maps that these are the pipelines you'll be seeing maps of. The distribution pipelines are generally smaller, and they take natural gas from the natural gas transmission pipelines, and they deliver it to our individuals' homes and businesses. Distribution pipelines are typically operating at much lower pressures than transmission pipelines, and there's no association to hazardous liquid pipelines. They use other modes of transportation to get to the end customer. So the schematic you see here just pertains to natural gas. And again, the transmission pipelines are typically about 24 to 36 inches in diameter. They're made of steel, and usually they operate between 200 and 1,500 pounds per square inch. Crude oil pipelines, on the other hand, transport, surprisingly, crude oil from oil fields to refineries, where the oil is processed into dozens of useful products such as gasoline, home heating oil, jet fuel, diesel, lubricants, raw materials for fertilizer, chemical, and pharmaceuticals. You can see the list up here on the slide. Typically, these are the gathering lines that you're seeing coming from the field. At the refinery, the refined products are transported through product pipelines to terminals and local distribution centers. Refined products are then distributed to the companies and consumers who rely on this steady and economically transported supply of these products. The product pipeline can be transporting dozens of products and grades of gasoline at the same time for a process that's called batching. Let me show you a little short little video here that demonstrates the concept of batching. So you can see you're having the hazardous liquids are coming along the line. The blue is representing diesel, the yellow is representing regular gasoline, and red is a premium gasoline. So they're batched, and as they reach the customer, they're then valved off and sent down to the holding tanks specific to the type of product that's being held. Here you can see finally the purple jet fuel has reached the airport. This is an asset map that I got from Sunoco's website, and it's a schematic. I just wanted to show you so you get conceptually the idea. The red line represents a crude oil pipeline, and the blue line represents a refined product pipeline. So there is only one pipeline in the U.S. that I know of that carries both crude oil and refined products. Typically, these are separate pipelines. I also used the example of Sunoco's website because a lot of the operators provide very good information for you in terms of planning on their website. You can see the products that are transported. You also get a lot of useful information about pipeline construction projects that they have either currently going on or will be planned to happen soon. This is just a schematic showing you the concept of gas distribution pipelines. And so these different colored areas are called franchise areas, and this is where your local distribution operator has an agreement with the state that they are allowed to operate business within these different areas. And again, these are the smaller, lower pressure pipelines that are bringing the gas from the gate stations, from the transmission pipelines out into your neighborhood. PHMSA does not collect maps about these, and typically your state pipeline safety office won't collect maps about these either. You really have to go through the 811 one-call number or through the pipeline operator. Let's talk about some of the things that you'll see about pipelines above ground in your jurisdiction. This is a picture of the transmission pipeline right-of-way, and it consists of a narrow, unobstructed strip of land. So the pipeline operator is acquiring easements along this string of contiguous properties, and the easement gives the operator the rights and responsibilities to construct, operate, and maintain that pipeline or pipelines. While the operator can control the type of activities that take place within the easement, They typically have no authority over the actions or type of development that takes place next to the right-of-way. Yet activities that occur next to the right-of-way can impact the pipeline, and the pipeline can impact the community that's outside the right-of-way. There could be multiple or just one pipeline within the right-of-way. Here the yellow line represents 2 underground pipelines, and the pipeline width can be as narrow as 25 feet to can be several hundred feet if there's a big pipeline corridor with multiple pipelines in it. This also illustrates the typical type of development that occurs as suburbs extend into rural areas. The transmission pipeline right-of-way is clearly defined, yet it blends in with the surrounding area. The shed and playground are outside the right-of-way, but the landowners are still able to enjoy the use of the land in the right-of-way. And I just put a screenshot from just to show you that in Appendix D of the PIPA report, which we'll talk about a little bit later, that it gives guidance about the type of activities that pipeline operators typically find acceptable on the pipeline right-of-way, and those type of activities that they typically find unacceptable. Varies from one operator to another, so you always have to speak to the specific operator and see what's allowable or not allowable within that easement as well. Here's another picture of a transmission pipeline right-of-way. This is in more of a suburban area, and as the development encroaches on these previously rural areas, we get higher density building going on. Sometimes the corridors, the utility corridors, end up being shared corridors. This pipeline corridor is shared between electric and an asphalt walking path. When you get more people within the right-of-way, there's additional needs for coordination. After the transmission pipeline is installed, the pipeline right-of-way must be maintained by the operator, and they have to inspect the surface conditions of the right-of-way. That's one of their requirements under federal regulations. Sometimes they fly airplanes over the top, so again, that's another reason why that right-of-way has to be clear, so that from that distance they'll be able to see if there's any leaks or dead vegetation or other signs that there is some type of a release from the pipeline. So extensive landscaping and other obstructions like that can block their view. In addition to their view, if there is a reason why they need to access the pipeline, it could be either, standard periodic maintenance operations of that pipeline, but it also could be in the event of a pipeline release that they're going to need to get to that right-of-way fairly quickly. And typically, they do vegetation clearing at some periodic interval within the right-of-way. The other thing about a right-of-way is that when you're considering that new development near the right-of-way, make sure that they still can get access from off the right-of-way to get onto the right-of-way. You may have noticed in the previous picture the pipeline markers. So here's some additional pipeline markers for you to see. Since pipelines are buried underground, the markers and warning signs are located at frequent intervals along hazardous liquid and gas transmission pipelines. They are also required to put those markers where the pipeline intersects streets, highways, railways, waterways, and other prominent points along the route. From a marker, you can identify the product that's transported and the name of the operator, as well as a telephone number to call in the event of an emergency. Pipeline locations within a right-of-way may vary. They don't always go down the center of the right-of-way. They might also have had to have an offset for some reason. So you can't use those markers to dependably rely on the exact location of the pipeline. Additionally, when there's more than one pipeline within a right-of-way, there will be a set of pipeline markers for each pipeline that's there. Let's look some more at some of the above-ground pipeline facilities. This is a picture of a mainline valve positioned along the pipeline system, and it can be closed down to isolate a line section for an emergency or as needed for maintenance. And these above-ground valves are located every 2.5 to 20 miles. The valve assemblies themselves typically require about 50 square feet and a road access. This picture is of a pipeline inspection gauge, or how we finally call them pigs, a pig launcher. Pigging facilities provide access to the pipeline for the purpose of cleaning, maintenance, and inspection operations. What they do is they insert a pig into the pig launcher. The launcher is then closed and the pressure-driven flow of the product in the pipeline is used to push the pig along until it reaches its receiving trap. The second picture shows a pig being inserted into a launcher. Notice the amount of space that it takes to maneuver the pig and to get it into the launcher. These facilities are usually smaller than pump and compressor stations that you'll see next, and they typically consist of one or more short sections of above-ground pipeline, valves, and other control equipment. Sometimes there may even be some small buildings or generators, and typically the area is fenced and surfaced with gravel. This is a picture of an oil pipeline being repaired. Notice the amount of room that's needed for repair activities. Pipeline replacement can require even a greater area during construction. Notice that, depending on the depth and the type of soil that you have here, the need to dig, further and further away so that your trench, it doesn't have, so that it's not going to cave in. Generally, only line pipe and associated appurtenances are located within the pipeline right-of-way. Tank farms, pump and compressor stations are generally located on company-owned property that's off the right-of-way. The pumping stations are located throughout the length of the pipeline to adjust for pressure, pump the product along the line, monitor flow, and other information about the transmittal of the product. Pumping stations are spaced between 5 and 100 miles apart, and that depends on the pressure that the pipeline is operating on, as well as the terrain over which the pipeline runs. Pumping station sites, which typically exceed about 25 acres, may contain large liquid storage tanks. Breakout tanks are used to relieve surges or to receive and store hazardous liquids for later reinjection into the pipeline system for further transport. Tank farms are for the storage of crude oil and or refined products. The products are usually transported to end users into further storage facilities. You see in the lower picture on the left, that there's been an oil spill, and it's remaining completely within that containment area, and they are required to design them to contain all of the pipeline that would be within one of those tanks. Compressor stations are to natural gas systems what pumping stations are to liquid pipelines. Compressor stations are located about every 40 to 100 mile intervals along the pipeline to push the product along. Generally, a compressor station occupies between 15 and 20 acres of land. There's over 1,200 compressor stations in the U.S. A city gate station, typically operated by a municipality or what we call a local gas distribution company. And again, it's the custody transfer between the transmission pipeline and the local distribution network. So the city gate, you're going to see an array of valves, pipes, pressure-reducing equipment designed to meter and heat the gas before reducing the pressure so it can be safely delivered into the customers through this distribution network, which consists of local gas mains, smaller diameter services, and individual customer meters. Additionally, I put a picture of an odorant tank up on the top, and the odorant is added to natural gas because natural gas is naturally odorless. So when you get into areas where there's higher population, the odorant is added so in the event that there is an unintended release, the public can smell it. And sometimes what happens is if they put in too much odorant, you start getting a lot more calls because it just raises the amount of odorant that's going out into the area. Also, if this odorant smells like rotten eggs, and if when they're filling the tank, there are spills, something like that, it can be, it's incredibly strong, the aroma from it. So this leads me to point out one of the recommended practices. It's called ND18, and it's talking about consider the noise, potential odor, those other sort of things, vibration that can occur at these above ground facilities. And again, just consider what type of a development do you have next to them. And when I say vibration, some of them, the vibration at under different operating conditions can like rattle plates off of the wall if it's very in close proximity to development. So let's talk a little bit about the benefits and the potential impacts of pipelines. Pipelines are indispensable. It's important for planners to understand the risks as well, though, and their ability to use the land planning tools to mitigate the risk. So as previously stated, our gas and hazardous liquid transmission pipeline system is a critical part of the U.S. transportation and energy supply infrastructure. The energy pipeline system serves most every community by supplying their commercial and residential heating needs. Airports and electrical power generating stations and major industries depend on the energy and raw manufacturing products delivered by pipelines. Virtually everything in the modern world is either made from oil derivatives, uses oil-based energy to produce it, or to transport it. So despite the relatively high degree of safety in transporting volatile gases and hazardous liquids, releases of products carried by pipelines can impact surrounding populations, property, the environment. It can also result in injuries and fatalities. Additionally, releases can have significant economic disruption, such as business interruptions, damaged structures and infrastructure, or a loss of supply of fuels such as natural gas, gasoline, jet fuel, and home heating oil. Pipeline events can cause a loss of confidence in and a loss of reputation, not only of the pipeline operator, the pipeline regulator, but also of the local government. Events can leave the public in fear that another event is going to occur. Pipeline emergencies have different types of characteristics, including the type of onset, the intensity, the impact area, and duration. And understanding the type of potential impacts plays an important role in land planning and development near pipelines. The following are some of the examples based on the pipeline type and commodity transported. Unintended gas transmission pipelines releases pose a primarily acute hazard. If an ignition source exists, a release of gas can result in an immediate fire or explosion near the point of release. This hazard is reduced over a relatively short period after the release ends as the gas disperses. But natural gas can also migrate, and if the vapors accumulate inside a building, then the hazard may remain longer, and it also poses a threat of explosion to that building. Pictured here is the impact of a natural gas incident that occurred in Appomattox, Virginia in 2008. The 30-inch diameter gas pipeline operating at 800 psi ruptured, and the gas ignited, producing a large fireball, resulted in a 37-foot long by 15-foot deep crater. The burn zone was over 1,100 feet in diameter, and you can see there were 2 homes within the burn zone that were destroyed. This is also a gas transmission failure. It's in a suburban area. This, in general, the larger the pipeline, the higher the pressure, the closer it is to people, and the inability of the pipeline operator to shut off the flow of product, the greater the potential severity of the consequences. This event occurred in San Bruno, California in 2010, and the impact included 8 deaths, numerous injuries, and the destruction of 38 homes. The U.S. Geological Survey registered the explosion and resulting shock wave as a magnitude of 1.1 earthquake. The pipeline was 30 inches in diameter, operating at 400 pounds, and the impacted homes were over 500 feet from the pipeline. The consequence of this failure were compounded because the explosion compromised a water main and necessitated that firefighters truck in water from outside sources. They ended up dragging fire hoses nearly 4,000 feet to the working hydrants. This pipeline map is from the National Pipeline Mapping System Public Viewer, which I'll tell you more about later. But just to let you know, anyone can view maps of their pipelines, hazardous liquid and gas transmission pipelines, without any password. Just go to the NPMS. You can see it based on one county that you select. It doesn't allow you to go in, down to the street level, but you can still get an idea of where these pipelines operate within your county. And I'll talk to you more in a little bit about the pipeline system that you as government officials can get, which provide more detailed information about pipelines. What's circled here, the pipeline represented in blue, is a hydrogen pipeline. And it's in Toledo, Ohio, and it delivers hydrogen from the hydrogen plant at the Sunoco refinery to the BP refinery. BP uses the hydrogen in a sulfur removal process to meet 2006 federal low sulfur fuel standards. A separate 8-inch pipeline runs alongside it and is used to return off gases, rich in hydrogen, from BP to Sunoco, which is again used to generate additional hydrogen. Hydrogen fires are significantly less radiant heat than natural gas fires, and it also rises very quickly. Hydrogen is like natural gas in that it's odorless and colorless and tasteless, and it makes it undetectable by human senses. This picture shows the sign of the natural gas distribution incident. It has the typical signatures. What happened is gas migrated into the house, the gas exploded, blowing the roof off the house, and the house was splintered and caught on fire. Local gas distribution incidents in general are confined to a smaller number, either one or a couple structures, not always, but this is a, what you would normally see in this type of an incident. Just to make it clear, the recommended practices that we're going to be talking about were not really considered for gas distribution pipelines, because these pipelines, by their very purpose, have to come close to development. It's coming to serve that house. So when we get into those, remember that we're really talking about those land planning near transmission pipelines. But I just wanted to give you an understanding of the different types and what type of incidents occasionally occur. Pictured here is a recent crude oil spill in Mayflower, Arkansas. It was a 20-inch pipeline operating around 700 pounds. The isolating valves on either side of the spill were 18 miles apart. So this picture demonstrates the type of impact an oil spill can have in development close proximity to the pipeline. This development was built in 2008, and the pipeline was installed, I believe it was 1948. So the pipeline was there many, many years before the development occurred. Let's talk a little bit about the refined products. Refined products are highly fluid, often clear. They spread rapidly on solid or water surfaces. They have a strong odor and a high evaporation rate, and they are usually flammable. They penetrate porous surfaces such as sand and dirt. They do not tend to adhere to surfaces, so flushing with water generally removes them. The volatile components, the strong smells that you can smell, they're of the oil. From the oil products, they can burn your eyes and skin and irritate a person's nose, eyes, and mouth. Generally, refined products tend to be more toxic than the heavy crude oil, but they're also less persistent. Heavier crude oils are less toxic because they do not evaporate, but they do remain in the environment longer. They are characteristically viscous, sticky or tarry, and brown or black, and flushing with water will not readily remove these materials from the surfaces. Hazardous liquid spills may have long-term potential consequences, as the released product can spread over land and water, flow into valleys, ravines, and waterways. There's a potential ecological damage and contamination of drinking water supplies occurring some distance from the point of initial release. Weather conditions and water temperature greatly influence the behavior of oil and refined products in the environment. This is an example of a highly volatile liquid. It is a hazardous liquid which will form a vapor cloud when it's released into the atmosphere. Highly volatile liquid pipeline operators are of pipeline operations are of special concern because their potential to be accidentally or unintentionally released into the atmosphere and impact large geographical areas and populations downwind of the release. An example of a highly volatile liquid product transported by pipeline is ammonia. There's also carbon dioxide, hydrogen, and liquefied petroleum gas, which we commonly refer to as propane. Some hazardous liquid products, such as the propane pictured here, pose primarily an acute hazard of fire or explosion similar to natural gas. These commodities have a high vapor pressure and are in liquid form when they're transported. However, if they're released from the pipeline, they convert to gas as the pressure is reduced. Propane vapor is about 1.5 times heavier than air, so when it dissipates readily to the open air, it will dissipate. But when in the right conditions, the propane can settle in low, unventilated areas and become concentrated if there's little or no air movement. So commodities with density greater than air have a stronger propensity to remain near the ground. The behavior of these commodities present different challenges to land planning compared to hazardous liquids or natural gases. This is a picture from an incident that occurred in 2007. It was a liquid propane line that ruptured in Clark County, Mississippi. And what happened was the seam split, longitudinal seam split of this 12-inch pipeline over 600 feet. And over the next 48 hours, 1,100 barrels of propane were released. The released propane vaporized and the vapor cloud eventually ignited. There were 2 fatalities, 8 injuries, and 250 people were evacuated from their homes. Anhydrous ammonia is the key nitrogen ingredient in the manufacture of fertilizer. It is also widely used as a refrigerant in many industrial facilities. It is also an essential element in the manufacture or processing of synthetic fibers, plastics, explosives, pharmaceuticals, and cleaning supplies. It has also been stolen to produce the illegal drug methamphetamine. Anhydrous ammonia is a highly volatile liquid that is transported in the liquefied gas. When it's released unintentionally, it will immediately return to the gaseous state and rapidly expand. It's highly corrosive and toxic, and the vapors are extremely irritating and corrosive, have sharp, pungent odors that act as a warning of the potential dangerous exposure. Exposure to very high concentrations can result in lung damage and death. And ammonia dissolves easily in water, and it's been known to affect water, lakes, ponds, and kill a lot of fish very quickly as well. I wanted to talk a little bit about the information that you can find on the Stakeholder, what PHMSA is. I know it just rolls right off the tongue. Pipeline and Hazardous Materials Safety Administration, what we call our Stakeholder Communication website. So this website is really built for any stakeholder, whether it's the public, emergency responder, emergency management, property owners, land developers, pipeline operators, everybody. We have different information in there. You can also get state-specific information, and I just made that a little bit larger so you can see. You can select your state and get information that's specific to your state. So there is a location within that, and I put the link down on the bottom, an example of Ohio. So you can see the total mileage in Ohio. Hazardous liquid, about 4,000 miles, about 10,000 miles of gas transmission, over 1,000 miles of regulated gas gathering, and about 57,000 miles of the gas distribution pipelines. Then you can also look at your county and see how many miles of gas transmission and hazardous liquid pipelines there are. You can also look and see a breakdown of what is causing the incidents to occur in your state. It's also broken down by the type of pipeline within your state. So, for example, again, I believe this is Ohio, but I don't have it. Oh, no, I'm sorry. This is the national level. So you can see the different categories that we use to categorize pipeline incidents: corrosion, excavation damage, incorrect operation, material, weld, and equipment failures, natural force damage, other outside force damage, and then the grouping of all other causes or unknown cause. Probably what's of most interest to you would be the red excavation damage portion. And this is the part which, as a state and local government, you play a certain role in, because these laws are set at the state level, and additionally you can set different permit laws at the local level that require those excavating to follow certain best practices. So I just wanted to point the information out that's on this page. And here's another screenshot from the National Pipeline Mapping System. Again, this is the public viewer. From it, what it's showing you is that you can select the little hand there, you click on the line, and it will give you information about the pipeline, the product that's in it, as well as contact information for that pipeline operator. And here's just came up on the right. That also, if you just want to look by a state or by a county without having to select all those different pipelines, on the front page of the National Pipeline Mapping System, you can just run a query by state or county or city, and it will give you the listing of all those pipeline operators. So what commodities are transported within your state? Again, you can find that out from the website. Here it shows Ohio. There's 9 different categories of hazardous liquid and gas commodities that are transported in Ohio. Most of the pipelines there are natural gas, crude oil, and refined products, although there still is a significant miles of propane, natural gas liquid, and highly volatile liquids. This slide shows you, again, what the screen's going to look like. You can see that you can select different types of reports. You can get information on incidents. You can get information on mileage, enforcement actions, information about your state regulator of pipelines as well, pipeline safety. You can drill down to the incident causes. You can drill down to the individual incidents and get information about, well, what type of impacts occurred? Why did those happen? How much property damage was there? Who was the pipeline operator? So you can look at the actual incident report. And either PHMSA or your state pipeline safety program is inspecting, and when we do inspections and find that operators have not complied with the regulations, then of course we enforce those regulations through the enforcement program. We list all of those as well on the Stakeholder website, so you can find out if there's operators that are not complying with regulations and what it is that we've required them to do to get back into compliance as well. I'm going to turn it, oh, not quite yet, a couple more slides. So I'm going to talk a little bit about government's role in public safety near transmission pipelines at the federal level, the state level, and at the local government level. So who regulates pipeline safety? At the federal level, it's the U.S. Department of Transportation, Office of the Pipeline Hazardous Materials Safety Administration, Office of Pipeline Safety. And we're here to ensure the safe, reliable, and environmentally sound operation of the nation's pipeline transportation system. PHMSA does not have any authority over the siting or routing of new pipelines. FERC does have some limited siting authority, and that's over gas interstate, so it's crossing between one state to another, gas transmission pipelines. And if there's pipelines, gas transmission pipelines that cross into another country, Canada, Mexico, obviously, those are, the new siting is regulated by the U.S. Department of State. Here's the Code of Federal Regulations Pipeline Safety if you ever need to look specifically what is it that we require operators to do. They're responsible for the safe operation and maintenance of their hazardous liquid and natural gas transmission pipelines. And the operator's responsibilities include taking actions to avoid pipeline damage or failure. And some of these actions include periodic testing, continued maintenance, development of emergency plans, performance of leak surveys, continuous surveillance. They have to do encroachment mitigation, and they have to patrol the right-of-way. They have to develop and implement damage prevention, excavation damage prevention programs, and also public awareness programs. What I think of their requirements of what you would find of interest is that the operator's public awareness program must specifically include provisions to educate the public, appropriate government organizations, as well as excavators on the use of the one-call system prior to excavation. They need to talk about possible hazards associated with unintended releases. They need to tell you the physical indications that such a release may occur, has occurred, steps that should be taken by the public in the event of a release, and procedures for reporting pipeline releases. They also have to talk to affected municipalities, school districts, businesses, and residents along the pipeline right away. So how about at the state level? Through certification by PHMSA, states can get certified to run state pipeline safety programs. The most common is they will have intrastate natural gas pipelines. So those are the distribution pipeline operators that have franchises within your area. Typically, those are inspected, enforced by your state pipeline safety office. In addition, under agent status, they can also acquire additional responsibilities for gas transmission pipelines as well as hazardous liquid pipelines. If they don't apply for and receive that certification, then those fall under PHMSA's jurisdiction. We also often get questions about hydraulic fracturing, and I just wanted to mention that that's at your state or local level, usually like your state environmental protection agency, but it's typically not PHMSA. And as I've mentioned, excavation damage is a leading cause or a primary cause of failure of pipelines, and each state has their own excavation damage laws. Some of those are stronger than other states. That's one of our outreach programs, is to work with states and make sure that they have effective codes and effective enforcement of those codes as well. All right, at this point, I'm going to turn it over to James to talk about your state and local role within pipeline safety.
Thank you, Julie. Again, as many of you know, for Land Use Planning and Development Authority, state and local government officials make important decisions that influence public safety near transmission pipelines. I'll give you an example here. PIPA set out to address the increasing risk to the community from the pipeline and the increased risk to the pipeline from the community that comes when they're in close proximity. Many transmission pipelines were originally constructed in sparsely populated areas, but subsequent growth of communities transformed some of these areas, previously rural and sometimes remote, into densely populated and suburban areas. So this graphic illustrates here land development growth on the transmission pipeline right-of-way in the state of Washington. So on the left, you see the location of that pipeline in 1990, which is, again, a remote rural area. But on the right, in that same area in 2002, just 12 years later. So quite expansive growth happened over that period. So PIPA's goal really is to reduce risks and improve the safety of affected communities and transmission pipelines through the implementation of recommended practices, which I'll review in a minute, related to risk-informed land use planning and development near transmission pipelines. Again, I want to make it clear here that these recommended practices are not regulations. And also, these recommended practices, as I think Julie alluded to earlier, are directed to transmission pipelines although some of the recommended practices may apply to gathering and distribution lines as well, but generally not. Okay, here you see an example of what can happen to close proximity of the structure to the pipeline, which makes access or maintain to or replace the pipeline or to respond to a pipeline failure very difficult. It also increases the likelihood of excavation damage to the pipeline. I think the picture explains that very, very clearly here. So understanding local land uses and human exposure to transmission pipelines has implications regardless of what actually triggered the pipeline failure. The increased potential for a consequence or an incident in the event of a pipeline failure to the occupants and the property due to the close proximity of the buildings to the pipeline should be obvious here in this picture. So this is an example of the increase in potential consequences of a pipeline release in which the right-of-way is only 15 feet wide and the buildings were constructed up to the edge of the right-of-way of a 10-inch pipeline transporting jet fuel to the Miami airport operating at 1,200 pounds. All right, so here's an example. You could choose choosing a better option. Using prudent land use planning, you can promote good planning in transmission pipelines, such as in this example. So what's happening here? Well, the developer, the pipeline operator, and the local government work together to create a development that was risk-informed. Again, you're not eliminating risk. That's impossible to do, but you're mitigating risk as best as possible. So the green line represents the pipeline in the pipeline right-of-way. The streets were designed to end in cul-de-sacs instead of crossing the right-of-way in all except the one street at the bottom of the slide here. So the houses are sited to minimize the number of homes that back up to the right-of-way. And the right-of-way is a soft surface walking trail which connects the community, so here in the way you have a win-win situation. So I want to talk a little bit about the PIPA report. I think Julie alluded to it earlier. And this was released to the public by PHMSA in December of 2010, and it's available on the PHMSA Stakeholder Communications website, on the website link you see there on the slide. And the report includes the following important sections: a definition of the key stakeholders who would be interested in this work, the risks and benefits of the transmission pipelines, and again the recommended practices for stakeholder groups, and an appendix that provides model ordinances and additional technical information. As all you planners know, all risk is local, so some local governments may want to adopt certain practices within their own development regulations, or some may encourage voluntary adoption by the local development community. We've seen examples of both these approaches, and they've worked very well. Really, these recommended practices are land use tools, but they're also hazard mitigation tools as well. So collaboration between the planner and the emergency manager can improve outcomes, and we strongly encourage planners to do that. And Julie mentioned this earlier, the National Pipeline Mapping System, which is a web-based mapping tool that allows users to view maps of hazardous liquid and natural gas transmission pipelines in the United States. Users can find basic information such as the commodity being transported and the operator's name and contact information. Very helpful information. The government officials can request shape files of the gas transmission and hazardous liquid pipelines to import into their GIS system. And there's also a public viewer where any member of the public can view pipelines in their county. So here's an example of a community that incorporated a transmission pipeline into their comprehensive plan. You can see the legend down below identifies the pipeline and the right-of-way, as well as the active pipeline and retired pipelines. So other local governments have mapped pipelines in their GIS, and they've used that for permitting and zoning. I believe some of the technical assistance grants that counties use address that issue. An important recommended practice is focused on the consultation zone. And what this does is it initiates a dialogue between the property developer / owner and a transmission pipeline operator where new land use or property development is being planned near a transmission pipeline. So the distance is determined in the consultation zone practice to be a trigger to alert the local government that they are in an area where they need to consider the risk of the pipeline to the community. So we recommend incorporating the coastal zone into a local ordinance. Again, what the zoning consultation zone does is simply alert the transmission pipeline operator that a development near its pipeline is being planned. It helps to protect transmission pipelines by promoting adequate consideration of the potential safety impacts of the development on the transmission pipeline, and on the other side, to raise awareness of the potential safety impacts of the transmission pipeline on the development. So here you see a map here. This is the city of Lenaxa, Kansas. We're at a consultation zone for a gas transmission pipeline and an electrical transmission easement. So what happens here is that when any proposed development is found to fall in within 500 feet of the infrastructure that's listed here, the developer will be required to meet with a holder of either the gas pipeline operator or the electrical power easement holder to allow for review of the proposed plans for the development. Final plans will not be approved by the city until a letter from the easement holder giving approval of the proposed development plan is received. So if any reason the plan is revised, another letter from the easement holder will need to accompany the revised plan. Another recommended practice focuses on new development for residential mixed use and commercial land use. As you can see in the picture here, cul-de-sac streets should not be designed crossing a transmission pipeline, as the only route of ingress or egress could be blocked during a pipeline incident. This development is cut off, as you can see, by the pipeline right of way. So response to an incident would be is compromised, and it can be quite problematic in this situation here. Another recommended practice focuses on the appropriate placing of a new parking lot with the pipeline and the structure that the parking lot serves. This practice will be applicable, for example, during the planning stages, let's say, for a new auditorium with an above-ground parking garage where an existing transmission pipeline runs along the property. So the recommended practice would consider that, since human occupancy of parking lots or parking structures is likely to be short-term and low density, it may be preferable to locate that parking structure to create a buffer between the transmission pipeline right-of-way and the other occupied structures. In addition, enhanced fire protection and or the use of materials and design providing enhanced fire endurance may be considered for parking structures adjacent to the transmission pipelines to further mitigate the impact of a potential pipeline incident. And here's a slide of additional design criteria that are recommended in the PIPA report. In addition, another recommended practice focuses on temporary markers for construction. This is really to reduce the risk to the pipeline and also to the worker and the public safety of all the workers by installing a temporary fence or markers delineating the extent of the pipeline right away. This hopefully will discourage heavy equipment operators from traveling over the pipeline or storing materials on the pipeline right of way. And last but certainly not least is emergency preparedness. Recommended practice focusing on emergency preparedness. Effective emergency response planning can reduce the risk of a potential transmission pipeline incident by providing for timely response and situational control. So what this calls for is local government emergency managers to work with the pipeline operators to review an existing right-of-way for an emergency response needs and take into account criteria such as access to shut-off valves, access for emergency response to personnel equipment, location or capacity of fire hydrants as appropriate, and potential ICS triage and staging areas as appropriate. So from the findings, operators could work with the emergency response organizations to develop effective mitigation strategies and then work with the planners to incorporate into the jurisdiction's land use planning policy. So now I'll switch it back to Jewel, and she'll begin to talk about the hazard mitigation pilot they conducted with VDIM.
Great, thanks, Jim. So in addition to the pilot, I'm going to give you the following slides are all different types of resources that are available to help you, help support you in the implementation of land use planning near transmission pipelines. So first I wanted to talk to you about a pilot that we did this was the PIPA communications team working with the Virginia Department of Emergency Management. And what happened is we saw that there was different state and local hazard mitigation plans that included the consideration of pipelines as a hazard. And some of them did a great job explaining the pipeline hazards and the potential impacts on the community. But it's kind of what we found similar in a lot of them is they didn't really know then what were mitigation strategies that they could implement at state and local levels to reduce the risk of pipelines to their community. So we ventured off with Virginia Department of Emergency Management, and the first thing they did is talked about, well, what are the different ways that pipelines should be considered within a hazard mitigation plan, and they came up with 3 ways. So 1, pipelines are in and of themselves a man-made hazard, so consider its impact on the community. They also considered that natural hazards present risks to pipelines. So, that being their bread and butter of what a hazard mitigation plan does, consider what's going to happen during these natural hazards and how can we mitigate those risks, and then also going into your CIRAs, how can we look at being prepared and coordinating a response for natural hazards. And then the 3rd bucket is pipelines are critical infrastructure, and this again in your CIRA becomes much more important, understanding of what are the economic impacts and other impacts from the failure of this critical infrastructure. So some of the potential hazard mitigation strategies that were identified are, just pipeline awareness, understanding that a pipeline is a potential hazard. Second one is the mapping of pipelines, which we highly encourage, before you know where's the location of the pipeline and what is its relationship to the built environment, it's, how can you then take the next step? So it's really the first step to take. There's also different state and local excavation damage prevention practices that can reduce the risk of pipelines. Additionally, land use planning, which we talked about today, and then finally, emergency preparedness. Do your emergency responders, your health officials, are they prepared to respond to a pipeline emergency? So we have 2 primers that are in draft, and they're being reviewed by our different stakeholder organizations, by NACO, NLC, and then also our pipeline stakeholders, American Gas Association, American Petroleum Institute, as well as our state pipeline safety managers, which is the National Association of Pipeline Safety Regulators, and also the National Association of Home Builders. Right now they are our only developer representative on the team. We're seeking others if you know of any who would like to join us. So after those are reviewed, we're working with FEMA to get them into the hands of your state hazard mitigation officer, and hopefully you'll find those of value. So we created one for pipeline operators to better understand the hazard mitigation planning process, and the other one is for hazard mitigation managers to understand pipelines. This is our PIPA website, and it has just all kinds of resources for you. So on the opening page, you can find the PIPA report. On the right-hand side, you can see another report that was created by the PIPA initiative, which talks about building safe communities, what is that risk and its application to local development decisions. Along the bottom, we have a toolbox for each stakeholder audience. As you can see, there's one for government officials, and here are some of the things you'll find in that box. One, this is what I call PIPA in 2 pages. It's the equivalent of an environmental site assessment list. So the idea is either the property developer and the pipeline operator get together and they complete this, or you as a local development within the planning process, you take a look at it and you see, is this development being incorporated to near the pipeline in a safe way? So you're collecting information about the pipeline, the type of development, is there going to be blasting, how will there be ingress egress to the pipeline right away after this development is. And what happens is, as you identify different characteristics of the development or of the pipeline, it will point you to the recommended practice that then will give you more information to help you guide your land use planning decisions. This tool is really a gap analysis tool. So what it does is there's 43 recommended practices. Not all of those are meant to be implemented by local government. Some of those are for pipeline operators. or for property owners. So what we did is created one for each stakeholder group. So the one for your local government group takes those practices which are pertinent to them. We've categorized them into the groups of land planning tools, maps and records, and communication tools. And it shows a short summary of the practice, the action that you would take, and then it leaves a space for you to put what you currently do today, and then based on your community's decisions, what type of practices do you want to implement. We also have examples of land use ordinances that other local governments have implemented. There's a model ordinance that's Appendix B in the PIPA report, and as well we have a link to the Municipal Research and Services Center of Washington, and they keep a tally of the local ordinances that they're aware of. And if you do have a local ordinance that's not listed there, please send them an email and they will add that to list, and it will be useful to other communities as well. We have promotional material about land planning near pipelines if you want to do outreach to your community or to developers. Please feel free to use this, and you can take off, like there is Enbridge, you can take that off and put your own community's logo on there. We also have technical assistance grants. Unfortunately, they just closed for this year, but it is an annual grant program that is awarded to help support communities. And one of the main reasons is to help support communities to implement PIPA recommended practices for their own community. It doesn't necessarily need to be a PIPA recommended practice, but you want to evaluate land planning tools in your community, things like making sure that you first get the pipelines into your GIS. Those are the type of things that these grants have been used for in the past, and certainly would be eligible for a grant award in the future. Right now, they're up to $50,000 per year, and there's in total $1 million. The Congress actually authorized up to $100,000 a year and $1.5 million in total, but due to the current situation, we were not authorized because we're under a continuing resolution to bump that up, but hopefully next year it will be. You can sign up for an alert at grants.gov, and then next year when the grant is open, then you'll be ready to submit your grant application. And again, here is a link to, you can see all the past technical or current technical assistance grants, so you can see what other people use them for. We also have an outreach group, one in every region of the 5 regions in the country, and they're there to help you. If you want to learn more about pipelines, you want them to facilitate meetings, that sort of thing, I encourage you to reach out to, we call them the CATS, the Community Assistance and Technical Services. So what are the next steps? Locate the pipelines in your jurisdiction using the National Pipeline Mapping System. Read the PIPA report, look at the tools, assess your community's level of risk tolerance for land use and development near pipelines. Put a plan in place to address your community's needs using the recommended practices. Consider enhancing your hazard mitigation plans to consider pipelines. And then contact your pipeline operators. You will find that in 99% of the time, they are happy to support you, provide you information about the pipelines that you'll need to develop your consultation zone distances or other land planning practices near their pipelines. I just want to leave you with one story. So I was talking about PIPA with a fire chief up in an area and showed him, this building which is in his jurisdiction, and said, this is one of our practices, ND22. It's to reduce that pipeline through the design and location of new places of mass public assembly. And I said, what we have here is a church next to a pipeline right away. Actually, it's only a couple feet off of it. So the entrance to the church where, the formal ingress, egress to this building goes right on top of that pipeline. And not only that, but it's just there wasn't a whole lot of awareness that this was a pipeline right away, right in front of the church. So it said, if you been able to read the practice ahead of time, maybe you would have rotated the church a different way so that, if there was a fire or something occurred, people wouldn't just automatically want to head out that door towards the pipeline right away. And also maybe you would have moved that building back as far as possible on that piece of land. Or maybe you would have just said, you know what, this isn't a good location for a place that's going to have a high density, high amount of people at one location, or someplace that's really difficult to evacuate quickly, like a hospital or a nursing home or a school. Maybe we just don't want them to be that close. And he said, you know what, now I'm going to go talk to them, but I'm afraid they're going to be mad at me because we let them build it there. And I said, that's not what we're about. We're not here to, we can't move those buildings, we can't move the pipelines, but we can in the future make better risk-informed decisions. So for now, what you can do is talk to them and make sure that they don't have their assembly point for their fire drills on top of the pipeline right away. Get it so that they're thinking, if something's happening, we're going to head out the opposite direction, away from the pipeline right away. So with that, then we'll go ahead and open it up for questions, and we have the little question thing here if anybody wants to send those to us.
Okay, I think there's an echo. Okay, first question is by Holly, who typically regulates and approves the design of the tank sites.
Of the tank sites. There are certain requirements on size, and they have to purchase that land so that, trying to think of what it's called, if there is an explosion, there's a certain distance that would impact, and they have to purchase enough land so that they're required by federal regulations as to the size of the land that they have to purchase. Does that answer the question?
Second question, excuse me, by Cherry. Do we need to be requiring that rights of way for pipelines be larger to accommodate safety needs, maintenance needs, emergency responsive needs?
We currently do not dictate the size of the right-of-way in federal regulations. That's a good question. I guess what a pipeline operator would likely tell you is that to purchase the land, which would include the entire potential impact zone, would just be cost prohibitive. But that's a good question.
And next question is by Matthew. How many miles or what percentage of pipelines are located on private property as opposed to within rights of way where the impacts of an explosion would be less?
I'm sorry, we're trying to look at it in writing. I don't see it. Oh, here we go. Okay, how many miles or what percentage of pipelines are located on property under existing development, as opposed to within right-of-ways where the impacts of explosion would be less. We don't collect that type of data, but generally the transmission pipelines are located on private property with an easement. Typically the operators don't purchase that property, they get an easement. And they also have certain rights under a common carrier under eminent domain. So there are times when, if the pipeline, if this is essentially in FERC, the natural gas interstate pipelines, they go through that FERC process, and when that pipeline right-of-way is approved at that point, or when that pipeline is approved at that point, they do have the rights of eminent domain to acquire those properties.
Thank you. The next question by James. Is there a team similar to FFA that reviews incidents? Is there a technical team to assist in emergency response? is the order added to natural gas lines at the production lines?
Okay. So the first one, is there a team similar to FAA that reviews incidents? There's two groups that review pipeline incidents. There's the National Transportation Safety Board, the NTSB, and they're an independent organization. They don't have any regulatory authority, but the larger incidents, they will go and do a very in-depth root cause analysis, and they actually take back samples from the pipeline failure to their own facilities to do their metallurgical examination.
They investigate all incidents tied to a transportation system, correct?
They do also do the FAA, the airplane, but they only select certain incidents that occur within each mode of transportation. So typically they look at the larger failures. Here at PHMSA, we do an investigation of every incident that reaches what we call a significant incident reporting threshold. So if there is a injury that requires hospitalization, a fatality, or property damage over 50,000, or if it's an oil spill, if it's over a certain threshold, that then we do an inspection. We investigate those incidents. So is there a technical team to assist in emergency response? It's different for hazardous liquid and for gas transmission. The EPA and the Coast Guard are the ones who work with the emergency responders for the hazardous liquid spills and on the drills. And for the gas distribution, gas transmission, as well as the hazardous liquid, there are groups that have training that they will provide to emergency response organizations. It's something that we've identified that we need to get more information out through fire chiefs and National Association of State Fire Marshals and those different groups. So we have some initiatives that are working to get that training out and to get funding on that currently. Is the odor added to natural gas lines at the production site? Typically not. There are some transmission pipelines that are odorized because they go through densely populated areas. But typically there's no odorant added until it gets to the gate station where there's that custody transfer from the transmission pipeline to the distribution company. And the reason why they don't like to put it in the transmission pipelines is that it can cause corrosion. Any type of additional liquids that you get in a pipeline, has the potential to cause corrosion. So that's why it occurs at the gate station. So the most densely populated areas, that gas is odorized.
Thank you. Next question is by Art. Are steps being taken to make the pipeline system more secure, either nationally or locally?
For secure, if you're talking about from outside threats, such as Department of Homeland Security would be interested in, there is a group within Department of Homeland Security which specifically works with pipeline operators in identifying, which ones are critical facilities and potential targets of those people with bad intentions. And it's a separate group from us. We're looking specifically at the pipeline safety regulations. If you're talking about secure in terms of improving the safety of pipelines, we work on that every single day of the year. We are implementing new regulations. We have several large ones that are in place that are currently in a proposed state. They're not in the final rulemaking. They're in all different stages of rulemaking, and you can look under the Federal Register or on the PIPA Stakeholder website, and I'd be happy to send you a link to see what those specific regulations are currently. So right now, some of the larger things that we're looking at is the location of shutoff valves, whether they should be automatically controlled or remotely controlled, whether there should be excess flow valves which shut automatically if there's a break in the line, on some of the areas that we don't currently require them. There's different regulations that are looking to expand our integrity management requirements from what we currently call high consequence areas onto other areas where there's lower population density. So we are writing a lot of regulations. We work closely with industry, with NTSB, research to try and find out more and more. And of course, every accident we take personally, and obviously we want to use those occasions as a way to learn more about pipeline safety. Obviously, nobody has perfect knowledge of everything that can happen to a pipeline, and they are buried. So when those unfortunate things occur, we do take those opportunities to try and learn from them and improve, either through advisory bulletins or through regulation to improve those safety measures.
Thank you. Next is by William. In Oregon, pipelines in the coastal zone need to be approved by local land use authorities, and the LNG permitting process has been contentious statewide with very active grassrooted organizations. Do operators have a history of attempting to avoid local land use control by approaching federal regulations, for example, FERC directly?
I have not really been involved in the FERC process. We do have a couple FERC team members on our PIPA communication team who probably would be more appropriate for them to respond to that. I think just like in any group of people, you'll get most pipeline operators who want to work closely with the community and select locations that minimize the risk to a community. And then, you'll always have some that, their bottom line might drive their decisions more than you'd want. So I would say that's probably not typical. Pipeline operators spend a lot of money on their outreach programs, and a lot of it, of course, is driven by regulation, the outreach that we require them to do. But typically they want to be a good neighbor with the people who live along the pipeline right-of-way, because they, the safety of the pipeline is enhanced when they have a good relationship with the pipeline operator.
And they also participated in the PIPA report as well, the development of that report. So they willingly came along and provided input into the publication of that document.
Thank you. Next question is by Dustin. Are there any examples of homes being devalued because of being located close to pipelines? Are realtors required to notify buyers that a pipeline is adjacent to the property?
I'll answer the second question first. So the realtors, that's actually a PIPA recommended practice, is for a disclosure notice, a statewide disclosure notice, when in close proximity to a transmission pipeline. And of the two that I'm aware, California and Arizona, they didn't go quite that far. What California said is at any property transaction that people be given information that the National Pipeline Mapping System exists, and through that they can find out if there's a pipeline near the property that they are purchasing. And then Arizona, I haven't read it in a while. It is up on the PIPA website for real estate commissioners. But I believe they have, and it kind of falls under any hazardous real estate disclosure, that it has to be disclosed if there's an easement, transmission pipeline easement on the property.
So basically the requirement would vary from state to state.
Yes, yeah. Absolutely. Those are, there's only one federal real estate disclosure that I'm aware of, lead-based paint. So that's really at the either state or your local real estate commission. So examples of homes being devalued. We get this question a lot, and there's conflicting studies on it. Some that will say that there was no impact, and some that will say, an impact of like 3 to 5% following a pipeline incident. but then typically after a certain amount of time, there is no difference. Is typically, and again, I want to give the caveat of there's conflicting research that's been done to it, but I would not consider myself an expert in any way, but that's what I've read so far.
Would the National Association of Realtors have any data like that? Or is it too specific?
That's a good question, yeah.
You may want to check their website, too. I don't know if they'd have it, but maybe good to check there.
Thank you. And next question is by Art. Are there any requirements for designing facilities in context with their surroundings, such as in rural areas, constructing structures that look like farm buildings?
I think there are any recommended practices. As far as the PIPA recommended practices, I don't think that the focus was on it. No, I didn't think so. And the requirements, again, probably would be based state to state. But I don't think that anything like that would exist.
Yeah, I have seen out in the real world, though, that some pipeline operators, they'll have little buildings that are in keeping with the type of buildings that are in the community, but there aren't any requirements.
Next question is by James. Are there recommended practices for local transmission pipelines? How many incidents happen per year?
Okay, so the first question, as I mentioned, there's both intrastate transmission pipelines, those that reside just within a state, and there's interstate, those that cross different states. So a transmission pipeline can be through the middle of a large city, through the middle of Las Vegas, through the middle of Chicago, or they can be out in rural areas. So these recommended practices were really written to consider any type of transmission right-of-way. Obviously, as land gets more expensive, the more difficult it will be to implement some of these practices. And then how many incidents per year? I think there's, on average, about 15 fatalities a year. And in terms of incidents, I would have to go back to the website, but there are several hundred, and of course it varies per year, and that's reaching the threshold of significant incident.
That's transmission and distribution, too, right?
Yeah, all different types.
All different types.
Yeah, thanks. And will the slides and audio be posted? I'll send that one to you, Ben.
Yeah, it will be on youtube.com/planningwebcast, and we'll put the videos there, and email planningwebcast@yahoo.com for a copy of the presentation.
And that looks like, is that our last question?
Yep.
All right. Well, I want to thank everybody for coming today, and I really appreciate your interest in pipeline safety. On the last slide, there's contact information for James and I. So please feel free to contact us.
Yes. Yeah, thank you for participating in the webinar today. Again, this webinar will be available to you, I believe, on YouTube. So we do appreciate the opportunity to present to you today. I think we had a good crowd and
good questions.
Good questions, too. So we do appreciate that. Anything else, Ben, that we need to do?
That's it. Thank you very much for speaking for us, Julie and James, and we really look forward to see you again.
Thanks for your support, Ben.
All right, thank you very much.
Bye-bye.
Bye.